Well, hello, everyone, and welcome back to this week's KM World Magazine webcast series event. My name's Andy Moore. I'm publisher of KM World Magazine, and I'll be your host and moderator today. Today's presentation is part of an ongoing series, as I suggested. Please join us for each of these events. Check the website for the schedule of these educational, live, interactive web events. I'm really pleased to welcome all of you to today's installment, which is a discussion that we're calling Maximize the Value of Your Information Assets with Advanced NLP, that's Natural Language Processing, Text Mining. We're going to get to that all in a minute, but here's the question. How are you currently capturing knowledge from your text-based information assets? Turning text into actionable insights is key for any business, especially those knowledge-driven industries such as life sciences and healthcare. There are others. Huge amounts of information exist in the form of unstructured text, such as scientific articles, patents, electronic health records, news feeds, social media, but this is all often poorly exploited. So that's what we're going to talk about today. This webcast demonstrates the state of the art in extracting information from unstructured text using natural language processing, NLP. Our speakers today, first up will be David Millward. David is Chief Technology Officer at Linguamatics. And following him will be Simon Beulah. Simon is Director of Healthcare Strategy for Linguamatics. I'll be introducing them in a moment, but you can learn more about them by clicking the speaker icon at the bottom of your console, and you can read a lot more about each of our speakers. Let's see. Some housekeeping first. There will be a Q&A session, as usual, after the presentations. You ask your questions anytime during the event, and you can start now if you like, by entering your question into the text box on your screen. Hit the submit button. I'll be reading your questions to the speakers aloud during the Q&A session at the end of the event. If yours isn't asked during the event, however, never fear. We will get you an answer offline via email. So any question is open game, so please feel free. We're also going to ask a quick pop-up question, a polling question in a moment. This is a very simple poll question, but it will put our speakers into perspective for today's conversation. So please take a moment to look at the polling question while I introduce David, our first speaker. Polling question should be popping up any moment now. Very simple. Have you used text mining ever before? It's a yes or no question. Think about it for a minute while I introduce David. David Millward, as I said, is Chief Technology Officer at Linguamatics. He has more than 20 years' experience of product development, consultancy, and research in natural language processing. He is a pioneer of interactive text mining and a founder of Linguamatics. He's also published in the areas of information extraction, spoken dialogue, parsing, syntax, and semantics. So he should be a pretty good speaker. Let's hope that we can get to David in a minute. I hope that you've had time to answer a simple yes or no question. Well, I'm a little surprised, David. I mean, text mining is not, I wouldn't think it was as well adopted as it appears to be by our group today. We've got almost 52% of our people who are familiar with it. Is that a surprise to you?
Yes, I'm very pleased to see that kind of figure, Andy.
Well, I'm surprised and pleased as well, and I'm sure that you are. Did you expect something different from this result?
I think it does depend on the kind of industry areas as to how well it's adopted.
Right.
So in some of the knowledge-rich areas, it's very well adopted, but less well known elsewhere, except in the sentiment area.
I'll have a peek at the attendee list in a moment and try to see what kind of industries, vertical industries, that we have represented today in our audience. But I won't take up any more of your time. I would like you to begin with your presentation. So please help me welcome David Millward.
So thanks, Andy. So I'm going to talk about maximizing value of information using text mining based on natural language processing technology. And we'll say a little bit about what that means as we go through the slides. So first of all, I'll set the scene, look at some of the challenges and trends that are generally occurring in this area, and then look at how text mining is able to address some of those issues. And then I'll talk a little bit about Agile text mining and show how that can also answer particular problems that traditional text mining has had, and how it's actually encouraged the adoption of text mining across wide areas of different applications. We'll then go into some case studies, and Simon will talk about a variety of case studies, including ones in the life sciences and the healthcare area, and then we'll move on to conclusions. So if we look at some of the trends that we have, firstly, a few years ago, people would say, well, actually, we don't need text mining. We have our experts, and they know everything that they need to know. I think that's really very rare now. I don't think I've met that comment for the last 5 or so years. There's just so much data out there, so much information out there, that everyone has trouble keeping abreast of the new information that they need to be aware of. But also, I think people also switch more often between areas. They go into different disciplines, and a lot of the discoveries tend to be across disciplines, certainly in the scientific areas. And when you're crossing disciplines, you tend to need things like text mining to really get good knowledge of the new area. I think other trends are that people want information immediately. They're used to using things like Google, and so their expectations have changed over the years. But they also have problems that they need to process it faster. So reading one document at a time from a search engine is often too slow. You just can't absorb the amount of information that you need in that kind of way. And we'll see how text mining can help us deal with that and get us away from reading individual documents and getting us towards synthesizing knowledge faster. There's also a trend of services and products becoming more personalized. And I think that goes across the board, whether it's targeted cancer treatments or whether it's shopping recommendations. And in both cases, the personalization is being driven by data. So you're using data and using data analysis to be able to personalize products and services better. And as with most areas, there's increasing expectations on knowledge management to then deliver and keep people abreast and able to deal with the information overload. So some of the challenges are that there's still a lot of unstructured information out there. So there's been efforts to get people to structure information more. There's been the move to the semantic web. But user-generated free text is actually increasing. We've got all the social media, and so we're getting a huge amount of free text. So the proportion of free text versus structured text is probably not changing very much. Gartner has said for some years, have estimated that around 80% of information is in the free text. And there's a lot of talk about big data, and that's talking about high volume, velocity, and variety. But a lot of that volume and variety is actually in the free text. That can be social media, such as blogs and Twitter, but it's also things like internal reports and presentations, scientific literature, patents, news, analyst reports. And all this data has a lot of variety in how it's structured. It can be semi-structured in different formats in XML. It can be PDF, or it can be image PDF, Word, or PowerPoint, for example. So there's a lot of different formats, a lot of unstructured or semi-structured text, and we need to exploit and deal with all of that. So when we're making decisions, we often want to answer quite specific questions. So it could be things like, how are people comparing my product with others? Or what are key opinion leaders saying about our product? It could be things like, Which groups are my competitors collaborating with? So those are quite general questions, which are going to be true of a lot of industries. But then there are very specific industry questions, such as which other diseases could my drug treat? Can I repurpose my drug for other diseases? It can be things like, what are common factors shared by patients who require rehospitalization and therefore cause a lot of extra cost to the health providers? So if we're going to answer those quite specific questions, can we actually use standard technology? Well, some questions have single answers, things like when was Barack Obama born, or which country won the FIFA World Cup in 2002. And for those kind of questions, you can use question answering technology, which tries to get you to a single sentence in a single document, which answers your question. But many of the questions we're interested in have hundreds, if not thousands, of answers. So for those kind of questions, we need to take information from lots of different documents, and we need to pull the information together from those different documents. And that process is very time-consuming if we have to go through document at a time. So what we want to do is go directly to answers, to lists of companies and people or products or relationships between them. So how does text mining fit into this picture? Well, text mining, in a broad definition, is just about processing the text to extract information. There's different kinds, such as information extraction, which tends to focus on going from the unstructured to the structured. So in this case, where you've got which companies are partnering, you might get a relationship extraction where you'll get companies such as Sanofi and activities such as bidding and the company that they're bidding for, Aventis. So you're taking unstructured text, such as Sanofi has made a bid for Aventis, and you're pulling it out, putting it into particular columns, putting it into a tabular form. You may standardize the company names to a standardized way of representing Sanofi or Aventis. You're taking unstructured data, you're standardizing it and structuring it. It also includes things like categorizing documents. You may be splitting the documents up into different sets. It can include statistical analysis, finding different trends across the documents as a whole. There's a narrow definition of text mining, pardon me, which talks about automatic hypothesis generation. And with this definition, what you're saying is that text mining is giving you new knowledge which you didn't have before. So generally, and I'd say most applications of text mining are really taking information which is out there and then finding the information which is relevant to someone's purpose. With text data mining, you're saying, well, actually, you can use text mining to also introduce new knowledge. You can take knowledge from different documents and then combine it together to introduce new knowledge. So, for example, you might have that a particular company is related to another company in one document, and then the second company is related to the third company in a different document, and that tells you that there may be an indirect relationship between the first company and the third company. And that's something you couldn't get from any one document on its own. And people use this for things like repurposing drugs, where you're trying to find new targets and finding ways that you might relate your drug to a different disease than what was previously known. So just recapping search versus text mining. So search tends to be about finding the most relevant set of documents for a particular inquiry. Text mining is taking the set of documents as a whole and then taking information out of that set of documents, whether it's trend information, particular relationship information. So it's less focused on individual documents, but more about the information which is in the document set as a whole. So text mining has been around for quite a few years, and it can provide accurate, comprehensive results. You can get targeted extraction of relevant information, which is often hidden in documents which might be about a different topic. So that's rather different from things like summaries or abstracts of documents, which tell you what a document's about. Often the thing that text mining will find is some occurrence somewhere in the document which wasn't necessarily central to it. So if we're interested in side effects of drugs, you might have a mention of a side effect of a drug in a document which was about a different drug. You can do clustering and trending analysis. hypothesis generation, as we mentioned in the last slide. But it's not a magic box. We're still some way away from understanding a whole journal paper, for example, as a whole. If you're to understand the paper as a whole, you need a lot of real-world knowledge, a lot of context to come in. So it's really successful when you're looking for specific pieces of information. But it's different from actually saying that you've understood the whole paper. And we'll also want to read the papers to justify our conclusions. So we can use text mining to come up with hypotheses, but we'll still want to read the papers to actually justify the connections between the different facts we found. So let's move on to look at Agile text mining. So Agile text mining is a technology that was developed at Lingomatics, and it was aiming to address a particular problem. Traditional information extraction systems need to be programmed by a combination of a programmer, a linguist, and a domain expert. And that's a really hard combination to find. And if you're reprogramming every time you have a new question, that's also very time-consuming. We wanted to address the issue that allow end users to be able to create their own query patterns. So just to say a little bit about Lingomatics, we're headquartered in Cambridge in the UK, but we also have offices outside Boston in the US. And we provide the I2E text mining platform, which is an agile information extraction platform, and I'll describe what that means in more detail. And we're used quite widely, particularly in knowledge-rich industries such as the life science industry. So 16 of the top 20 pharmaceutical companies use the technology. We're also used in healthcare with institutions such as Kaiser Permanente and in government such as the FDA. So what is Agile NLP and how does it differ from traditional NLP? Well, as I say, the traditional NLP is powerful. It can pull out those relationships, those lists of companies and people, but you have to program it, or you have to learn it from annotated data. And annotating the data is also very costly. Agile NLP is based on the combination of search technology and natural language processing. So it pulls together natural language processing, search, and the use of terminologies, and together those give you the interactivity and scalability of the search system so that you can quickly create new query patterns. It means you can refine your queries and develop them iteratively. Just as with a search engine, you start with one keyword and then add another keyword. With Agile NLP, you can add particular keywords or constraints and develop those constraints and immediately see what the effect of adding those constraints is, just as in the same way as using a search engine. And you can actually use a data-driven approach to exploit the unannotated data. So you can use the data itself to inform your search strategy. And that actually allows you to develop your searches much faster. But under the hood, you've still got all the power of the natural language processing, the linguistic analysis that would be in a traditional NLP system. And you can also pull out the structured results that you get with traditional NLP. So let's see what would happen without terminologies. If we have a question like, which genes affect breast cancer? Pardon me. We would actually have to put in a long list of terms. In fact, we might have to put tens of thousands of terms in to represent all the different ways that a gene might be expressed. That would be pretty impractical. We'd also have to look for something like breast cancer. We can look for breast cancer or breast tumor or breast neoplasm as synonyms of breast cancer. But we'll also be interested in this kind of query in all the different kinds of breast cancer, so all the children of breast cancer, as well as the actual term itself. So if we're going to put those terms in, that's also going to be thousands of terms in that side. So this is what we need text mining to do for us. We can actually put in a query where we just select a node for human genes that pulls out all the different genes, all the different ways they can be referred to. We can similarly look for any relationship between the genes and diseases and pull out all the different relationship terms. And we can look at all the different ways breast cancer can be referred to and all the different more specific forms of breast cancer. But that's using the terminologies and using the natural language processing to find the relationships. And then when we get our results back, instead of a list of documents, we get a list of the genes that are implicated in breast cancer. We can go down that list of genes. We can open up the 470 documents mentioning ERBB2, but we might not have to read all of them. We might only have to read the first one, find that there really is an association, and then we can move on to the next paper. And that means that we can actually traverse this tail and go down this list of genes, check each of them, and we can do that. In this case, we may only have to read 10 papers rather than reading the 1,000 papers in this selection. So when we're using natural language processing, we're using linguistic patterns. And the advantage of doing that is that you can pick up the different ways that people express the same concept. So if people are talking about a risk factor for diabetes, they don't just use the words risk factor, diabetes, all in one string. You get a lot of variety. With the linguistic patterns, you can pick up all that variety just with one expression. So we can pick up all the different things like risk factor or potential risk factor for incident diabetes or whatever. Similarly, if we're trying to, in social media, we want to distinguish people who are actually deciding to get a flu shot or not get a flu shot. Because once we can partition people who are making a decision one way or another, then we can see how they're being influenced. So in this case, we're looking at ways to see if someone is actually going to get a flu shot. And we want to get people who are actually getting a flu shot themselves, as opposed to talking about other people getting a flu shot or their sister getting a flu shot, for example. And we're using, again, the linguistics to find the many different ways that people can express getting a flu shot. And this is an example of what coming out of Twitter. So we can use the natural language processing to find different concepts. And then we can also discover within particular contexts. So if we're interested in what are the risk factors for diabetes, we can run these queries over a set of documents. And in this set of documents, we get that smoking is a risk factor, alcohol, diet, alcohol intake. And actually, 10th on the list, I think, was actually television as a risk factor for diabetes. So we're using now the data itself, and culling from the data, we're discovering what are the different risk factors. And that's a key fact. You can pull out of the data things that are of interest to you. Now, we can also structure things more formally. So if we're looking at chemicals, we can actually pull out the chemical name, assign it a particular chemical structure. We can take a particular gene or protein, and we can give it an identifier, in this case, in the Entree gene ID scheme. And we can also take out the relationships, and in this case, we've got a selective inhibitor, which means that in this case, that the chemical is inhibiting the gene. So we can take the way it's expressed grammatically and then create a relationship that it's the compound inhibiting the gene versus the gene being in the relationship to the compound. So we use our terminologies and our chemical recognition to actually assign meaning to the entities. We use our grammatical constructs to actually work out what items in relationship to another and what the direction of the relationship is. So over the years that text mining, so Agile text mining and I2E has been around for just over 10 years. And during the time in the pharmaceutical industry, we've seen it expand to cover the whole product life cycle. And I don't think there's any particular reason why the pharmaceutical industry is special in this area. It is very knowledge rich, but I think in other domains, you get the same phenomenon. You've got different questions you want to ask all along the product development life cycle. And we've seen new applications coming through. Our customers are inventing new applications all the time. So lots of different applications and applied to many different document sources, whether news or patent documents, scientific literature, internal documents. It can be 2,000-page internal documents, as well as social media where you've got 140 characters. in a Twitter feed. So general sources as well as specific sources relevant, for example, to the life sciences or to healthcare, where you're looking increasingly at inside the electronic health record. And the data sources themselves can be stored locally or on the cloud. So a few years ago, we introduced a hosted version of the I2E platform to deal with sources of data such as Medline, patents, FDA drug labels, common data sources, so that people didn't have to all index and update the information themselves. But we actually found that we got a lot of interest from large customers who wanted to both mine their internal proprietary content and also access the hosted content where it was a standard data source. So you can actually you can use the same client and you can seamlessly search your internal content and your external content. Another trend, I think, which has been very prominent in the last few years has been embedding and automating the use of Agile text mining. So once you've built up various applications, you've built up useful queries, you then may want to keep running those every week, for example, so that you can send alerts to people who are interested in those results. And so you can integrate the text mining with workflow tools such as Pipeline Pilot or KNIME and produce various different, and we provide a web services API so that you can also integrate with any other kinds of programs and then produce specialized applications or dashboards for different communities. And so there's some examples here of looking at phases of clinical trials, looking at some chemical structure properties, or looking at heat maps, for example. So effectively, the text mining is becoming really an enterprise semantic engine, which is driving different knowledge management applications throughout the enterprise. So it can be things like alerting services. It can be enhancing enterprise search, and I'll say a few words on that in the next slide. It can be taking the knowledge you've extracted from the literature and feeding it into semantic stores. It can be providing live dashboards. It can be also used for terminology development, which can be used feed back into your text mining system, but also feeds into some of these other systems, especially things like the enterprise search. It can be used for end-user portals, so moving from the information professionals who might be doing the professional searches, they can then present some of their queries in a parameterized way to end users. So to give an example of semantic enrichment for enterprise search, this is an example where I2E has been used to analyze the documents and pull out various factors about the documents. So it may be categorizing the documents. It can also be looking for various concepts within the documents, such as diseases or drugs. And this is an example where you picked out the diseases and drugs, and this is an example where the results are put into SharePoint, and you can provide the disease and drugs as facets for SharePoint. You can also use the text mining results to allow you to do concept-based searching. So when we're searching for paracetamol here, we're also finding acetaminophen. To give an example of populating a semantic store, there tend to be a few different approaches. One approach is to try to extract everything. This is typically quite challenging because you tend to have to make assumptions whenever you're extracting information to create a database. And that's true whether you're using text mining or doing it by hand. You have to make decisions. Do you include negative statements or speculative statements? What parts of the context around the statement are you going to include with it? So you have to make those decisions, and sometimes for different applications you need to make different decisions. For example, speculative statements can be really useful when you're looking for new information. When you're looking for things which are relatively rare, you may want to find stuff which the latest research on it, whether or not it's well established. But for other purposes, you may want to not include that in the database. So that's one example where sometimes people will say, well, actually, it's better just to extract as required for the task and create databases on the fly. You can also use text mining to see what's in the data. That can be useful when you're creating a database schema, for example, because often you can ask the users what kind of information they want, but often when you look at the data, you find there are obvious holes in the things that they've suggested. So you can use text mining to actually refine the schemas before you start populating. With extracting specific relationships, you can use the text mine to fill in gaps in structured data, or you can add data from a free text to the existing structured data, whether that's information from legacy documents which don't yet have structure, whether it's dealing with different updates to the data so that you can pull the structured data in more quickly. And it can be that you'll have missing relationships. So you may have structured data for compounds to diseases, but you might be missing structured data from genes to compounds. So having a look at a particular example here, in this example, we're pulling out relationships between genes and diseases, but we're focusing this particularly on the biomarker relationship. So we're getting on the first line, we've got TRIM25, and that's a standardized name for the gene. And in the text, on the right-hand side, we've got estrogen responsive finger protein. So that text has been standardized to the TRIM25 on the left-hand side. With the relationships, we've got as a new potential biomarker for, or as a prognostic factor is an independent prognostic factor for. So those are some examples of the linguistic relationships between the gene and the disease. And you can see some of those are relatively long distance, and all of those are pulled out by a single linguistic pattern. In this next example, we're showing some extraction of numerical information. So in this case, we're looking at particular dosages. We're looking at compounds. We're looking for safety effects found in the documents, and then we're looking at dosages. So we're able to combine together information, numerical information, with other information from the document. And we can also pull out information at different recall and precision. So we can decide to be really sure that we're going to pull out every safety issue we find, but we can then say for the dosage we want to only pull out the dosage if we're really sure about it. And so we can mix and match our different levels of how precise we're going to be. Those were two examples from the drug discovery and safety area. We could also do things like pattern landscaping. This is an example where we're looking at hybrid cars. We're looking at the different companies involved in patenting on hybrid cars, and then looking at the relationships between the different patents and visualizing the results. This is actually a case where we're feeding the text mining into the pipeline pilot workflow tool, and then it's pulling out the visualizations based on the workflows provided. We can also look for information about different individuals. We can pull out things like the companies they're working for, what degrees they have, what positions they have, what telephone numbers are available. So for different individuals, we can effectively profile the individual. So we're pulling out different pieces of information from different documents and assigning it to one individual. And we can profile an individual, we can profile a company, or a particular compound, or a gene. So you can take the same kind of approach to lots of different kinds of entities. A rather different example here is one looking at sentiment towards political leaders. Now, this one's an interesting case because you can look for things like positive and negative words, but context is really important in these cases. So you don't want to say, just by the word like being in the context of the political leader Clegg, you don't want to say that that's actually going to be positive about Clegg. In this case, it was don't like. So we had a negation right before the like. But you get more subtle cases, like look a bit like. That doesn't mean the person likes Gordon Brown. It's just someone else looking at like Gordon Brown. In the final examples on the page, we've got if Cameron wins this year's election. That doesn't mean someone's predicting that they will win it. And with this kind of political debate, you get a lot of hypothetical discussion, a lot of negative cases. You also get quite a few jokes which you need to filter out. So you need to look at the context around things to actually get, and you need to use this linguistics to actually work out what's really being said. Again, a slightly different example here. We're pulling out quotes from different people about different kinds of green energy, whether it's wind, solar, or waves. And we're seeing which quotes are positive or negative, clustering them by time. And this is an example of a free mind visualization. So once we're getting the data into a more structured form, we can slice and dice it, visualize it in lots of different ways. So I'll now hand back to Andy to introduce Simon.
Very good. Thank you very much, David. We'll get back to you in a minute during the Q&A. And in fact, I want to remind the audience that there is a Q&A session after Simon's presentation. So please feel free to ask any question that you like. As I said, we'll either get you live or we'll get you via email after the event. But I don't want to take any more time from Simon. Simon Beulah is Director of Healthcare Strategy at Lingumatics. Simon joined Lingumatics in order to lead the strategy for healthcare, which is a fairly new market for that company. But Simon has been working in life science and healthcare informatics for more than 20 years, initially in research, and for the past 14 years for informatics vendors, for various informatics vendors. You can read more about Simon by clicking the speaker bio tab at the bottom of your screen. But I don't want to take up any more of his time, so please help me welcome Simon Beulah.
Thanks, Andy. So we wanted to spend a few minutes just looking at some specific case studies, things that we're seeing in the industry, particular challenges that we're looking to address. So the first example we're going to look at is real-time decision support with clinicians within a hospital environment. Very important for clinicians to have access to very specific, timely information to help them make decisions as they're treating patients. And one issue that can often come up is if there is a particularly complex set of diseases that a patient is exhibiting, and the clinician is very interested in finding out if there are clinical case histories available in the public domain in scientific literature that match the patient that they're seeing, so that they can look at clinical risk factors, they can look at potential outcomes and treatment options, and it's really providing a real-time capability to support this decision-making process. Previously, the people involved in this, the information specialists who work with the clinicians, would have to go away and perform specific searches on their desktop machines. What we've been able to do is to implement a tablet-based system where the informationist is able to enter in the disease combinations in real time on doctor's rounds, go off, find the information, bring the information back again, read out the findings to the physicians present, and really enable them to make much more informed and speedier decisions. The papers can be passed on and emailed to the physicians so that they can read them later on, or just have them as a record of the decision-making process. It's a really exciting, interesting project. Has turned the information person in question into, as he puts it, something of a rock star. Everyone's very keen for him to be on rounds and make sure that their questions can be very effectively answered. So we're very excited about that particular project. The next example is with Huntsman Cancer Institute. This is Really the type of project that David was referring to, where we're extracting information from textual data sources about patients in this case. We're looking at very complex information in pathology reports. These are very often quite long documents. There might be multiple versions of them. And pulling information from those systems has generally only been possible by doing this by hand, by an abstractor reading the information and cutting and pasting it into a structured format. And this may take a few hours to do that per patient. What we've been able to do is to automatically extract the information using I2E, natural language processing. And it's really, looking to transform how you can turn very complex unstructured text into something that's structured. The structured data is so important in medical research, in medical analytics, in understanding populations and population health requirements. So once you've done that extraction, it can be applied in a lot of different ways, can support a lot of different use cases across many different departments. So it's a really important area as we move into a more transformative transition stage for healthcare and start to look towards a risk-based pay-for-performance type of reimbursement. You really need to understand the patient populations and really get at the rich data. You need more detailed information than simply what disease the code, what disease reimbursement code was assigned to that particular area. So that's, again, another very interesting and actually quite groundbreaking area. Another example is in competitive intelligence. We certainly see a lot of interest in this space from our pharmaceutical customers, but also in a much wider environment. If you're tracking what's going on in your marketplace, as we all do, in terms of seeing what competitors are doing and seeing what the market reaction is to their products, there are a growing number of sources that you have to look at. The scientific literature, there's news feeds, there's websites, there's blogs, there's an explosion in new media from Facebook and from Twitter and those sort of sources. And as we alluded to earlier on, the ways in which you have to mine and interact with these different sources, it varies depending on the information. A scientific article is very different to a Twitter posting, and you need to use specific techniques for each area. What we've been able to do is to look at each different type of source, come up with querying strategies, and combine that information together and deliver it to the end users via Excel spreadsheet alerts, weekly updates of information on what's going on in the market. And this is absolutely mission-critical information. Every company needs to know exactly what their status is within the marketplace. They need to be tracking what their competitors are doing, what's the latest news, what's the latest input. I think a weekly update is maybe a bit slow for some industries. It's okay for life sciences, but certainly alerting type systems that push the data to the end user as soon as something new and interesting comes up are certainly feasible as well, and something we're working on quite readily. So I think that the growth of social media is really transforming what you need to know about your marketplace and what's happening, and it goes way beyond just looking at the sentiment of a post. It's really understanding what's going on and what trends are being seen. Another really key area, particularly for large corporations, is looking at the patent landscape. Freedom to operate within a patent landscape is absolutely key. I've got to understand my IP position. I've got to understand the IP position of my competing organizations. One of the really important aspects of this is being able to deal with chemical structures. So a chemical structure can be represented in a number of different ways. It can be drawn as a 2D structure. It can be presented as a string of letters. And you need to be able to move between those ways of representing a chemical structure and then look within the textual information to find out where a particular structure is being mentioned, what's the context it's being used in, to really make sure that you fully understand what the patent landscape is. And patents are very complex, as we know, often quite obfuscated linguistic representations, which really require a very powerful assessment, linguistic analysis to be able to extract information and provide a summary of the landscape. And one example of that we can see here, we're looking at a chemical structure which is being represented in multiple places within the document. So we need to be able to say, okay, this string represents this 2D structure. We need to be able to identify that this particular compound is inhibiting something at a particular macromolar level. We need to understand that there's an interleukin-1 beta target that's being affected by this compound. We're pulling information together from lots of different places and then merging it all together to give one single view of that particular compound within that patent, and then combining multiple patent documents together to see what the IP landscape is around those. So it's a very complex area, and it requires a lot of sophistication to be able to do that. So I'll now hand back to David for some closing comments.
Thanks, Simon. So I think hopefully we've shown that text mining allows you to get to relevant information, and it allows you to get to it in an efficient way. You're structuring the data. You're not having to read every document at a time. You're clustering the information so you get to the information you need faster. We also looked at agile text mining and looked at the ability to create your own queries, so the flexibility to create your own queries, which means you can answer the long tail of less predictable questions. If you're not programming queries in, then you can be flexible. You can start with one question, and then within the next 5 minutes, you may be changing and adapting your question according to the things that you find in the data. And you can combine together lots of different information, whether it's using the natural language processing, the terminologies, the numerical expressions, chemical substructures, and similarity searching. You can combine those different search methods to get together to give you good filters, and then present the information in a structured way so you can quickly slice and dice it and use the information. We talked a little bit about using the data itself, a data-driven approach for being able to refine our search strategies and build terminologies. And please, we do have a webinar series, so if you want to have more information on all of this and see some live demos, please do attend them. And we've also talked about how we're more directly getting to answers, being able to integrate with existing structured data so we can exploit existing workflows, add to what we already have. And we can also use text mining as effectively as a semantic engine to also help our enterprise search engines, make them easier to use, provide faceted search so that people can get to information faster. So we've got a wide range of different applications of text mining wherever there's a need to search, extract, or categorize information. Thank you.
And thank you, David. Thank you very much, and Simon also. This is Andy again. I want to point out that the Q&A box is now wide open. Please insert your questions, and I'll be asking the speakers today your questions live on the air. Also, as I pointed out a couple of times, I'll be able to get you an answer afterwards via email. So please feel free to ask any questions that you would like. I want to point out before we go to Q&A that we'd like you to spend a couple of minutes looking at this survey that's on your screen now. Please answer the survey. It helps Linguamatics, it helps CAM World, it helps us organize and plan for future events. So please take a moment to look at the survey, which is on your screen now. And while you do that, I'll get to some questions that are on the Q&A board. I have to change hats here. Hang on one second. Someone, I think it was David, mentioned social media. And, you know, obviously that's a hot topic among people these days. David, can you kind of underscore and explain what text mining has to do with the social media and how it can add value and benefit to a company?
Yes. So social media, it's quite different text from, say, scientific literature or patent text, but there still is some structure in there. And you find that with the natural language processing, you can still use that to capture the different ways people express the same concept. So even though the sentences are short, the utterances are short, they're not normally full sentences, it's still really useful to use the language processing. And it means that you can generalize, you can divide the population up into different categories. You can analyze things like comparisons between different products that are being mentioned in the social media. So as social media gets, and I think every time we look into it, we find we're surprised by just how much detail there is. So yes, there's lots of noise, but you can filter down to the things that are really relevant to you. And once you get to that filter set, just because there's so much data out there, you find really interesting things. We recently did a project where people were actually looking for new ideas from the social media, and we were actually able to pull out where people had made new suggestions in the social media, which were then useful ideas that people could take forward. So there's a wealth of data there, and it's a wealth of data which isn't the traditional kind of positive or negative words that a lot of people are using it for.
Right. I've always kind of resisted the term unstructured data because it's not necessarily unstructured, it's just not very structured.
That's right, and we do use, I mean, if the data's semi-structured, then we'll always use any structure that's there, and particular, if they're index terms, they're also useful to use. They can still help you refine down, and then you can better analyze the free text that remains.
This might be a good question for Simon. Coming from Richard in the audience, he wants to know about, can you tell me how this, if this, is being used by government public health entities?
Yeah, that's a great question. We're certainly seeing a growing interest there. As I said, population health is clearly an area that depends on data as much as any other. We're mainly working, I'd say, on the payer side at the moment, looking at population health and kind of larger populations, how you extract information to support the modeling and assessment of different populations and care provision. So yeah, I see that as a growing area. I think those areas particularly are interested in things like fraud detection as well. Yeah, I certainly see that as an area that we're looking at the moment. I think from a government perspective specifically, I think we mentioned earlier on, we do work with the FDA on safety assessments, adverse event assessments, where I2E is used to help to mine the reports that come in about drug side effects and help to understand clustering within individual drugs and drugs that have the same method of action.
Yeah, I noted earlier, or maybe I didn't note, but I meant to note earlier that this is a relatively new area for your company, and you've come on to do this. Is this one of the driving factors? I mean, is this the reason that you were brought to Lingwamatics?
Yeah, I mean, healthcare fundamentally has a lot of information in text formats. Various estimates of 75 to 80% of information in an electronic health record is of an unstructured format. Right. And as I said, the really interesting insights and richness of information is captured in an initial assessment or a discharge document or a pathology or a radiology report, and those are the areas that are really important and valuable in terms of modeling outcomes and understanding treatment impacts and predicting things like rehospitalization. So it's there's a huge interest, huge demand for NLP in healthcare.
And David, I promised earlier I would scan the attendees and have a look, and boy, it's quite a spread. I mean, there's everything from healthcare, of course, to manufacturing, to media companies, to educational institutions. Where do you think the likely growth areas are going to be for text mining coming up the question was in knowledge management, but I could ask you that in general. Where do you think the growth areas in text mining will be occurring?
Well, I think health is one of the areas where we obviously see an increasing need. People need to have meaningful use of their electronic health records, and most of the efforts so far have been in the kind of billing code area rather than using the electronic medical records to really inform healthcare. I think generally, things like the pharmaceutical industry was one of the early adopters because it's very knowledge rich, it's very competitive in using scientific knowledge, and we'll see other industries follow. I think all industries are becoming more and more knowledge rich over time, and they will need the same tools. I think we're seeing one of the interesting areas, I think, is the growth in embedding text mining into workflows, things like the alerting systems. I think that allows more people to have access to the results of text mining. So I think it's starting to, the role of the information professionals is changing a bit. It's rather than answering questions, one-off questions, it's sometimes producing ways of providing alerting or user portals so that those questions can be answered by the end user more. So I think we're seeing a variety of trends, and given the amount of information coming in, everything needs to be more and more automated so that we can actually spend the time on doing the more intelligent analysis of the data rather than just being overwhelmed by the information that's coming in and doing quick filtering. That's the kind of thing that we need to leave to the automatic tools.
Well, and that actually touches on a question from the audience too. From I hope I pronounce this correct, Serini, who wants to know about how you apply domain-specific information, such as in healthcare and chemical and pharma, in your tools to, specifically analyze in those business areas, the content.
Yeah, so that's a very interesting question, because if you are in something like the life sciences, there are a lot of terminologies out there, but then it's a domain where you really need it, because there's different concepts will be referred to in many different ways. So it's a challenging domain, but there are good resources there for terminologies. When we go into other domains, there's often not quite as much of a problem with the same concept being referred to in so many different ways. But you have to then plug in different terminologies for that domain. And people actually use I2E itself to actually cull terminologies from the data. So you can use it as a way of actually introducing new terminologies where they don't exist. And we've been very careful to have an architecture where you can plug in different terminologies which you particularly want to use. And sometimes people will take the same data set and have different terminologies on it. So the medical practitioner may be used to a different kind of concept space than a research scientist. So we want to allow people to have their own ways of dividing up the information, their own terminologies, and plugging those into the system.
Right, I'm sure. And Simon, I'll let you have the last comment on that subject, because I think that you might have some insight into that as well.
Yeah, certainly in the medical domain, there are many different ontologies that can be used to drive these types of processes. They have varying degrees of detail captured in them. So something like an ICD coding ontology not particularly detailed, whereas something like a snowbed is far more children and far more synonyms captured within that environment. So from an NLP perspective, having lots of different representations of each term and being able to identify those concepts within the text is absolutely fundamental to what we do. So it often is the case where we'll have a basic ontology, some form of medical ontology that we use to drive our processes, but then we will supplement that with a data-driven approach that looks at the terminology that we see at that particular customer or organization. So we'll have a baseline, and then we will improve the precision and recall based on their own terminology.
Right, and their own terminology. I'm glad you brought that up because I was going to ask that question, and that is whether you find that your customers have their own, what are termed folksonomies, their own internal language and their own terms that they use to describe things that are different from maybe the general population's terms.
They absolutely do. And what we need to do in that instance is to let the data tell us what the distribution of language is for that particular customer, make sure that we extract the appropriate terms, and then we need to make sure they're mapped into the kind of industry standard structures so that we normalize the data and semantically enrich data in the right way. So that it's a multi-step process, but it's very important to bring the internal and external world together in that way.
Well, David and Simon, we could talk about this all day. I'm sure we would if we were given the time, but we don't. We're now out of time. We're past the top of the hour. I want to thank both of you for coming today, David Millward and Simon Bella. Sorry. I knew I would mispronounce it eventually. Simon Below. And, of course, Linguimatics for helping us with today's great presentation. Thank you very much for everything. Thank the audience for coming. In fact, if you want to preview or review this event or send it to a colleague, you can go to this URL that you used today. We'll archive it for 90 days. You can always come to any of our archived events at www.kmworld.com. Now, if you stay on the line, you'll be redirected to more related information to today's event. So please stay on the line, and you'll be escorted over to Linguimatics site, and you'll have more access to what we were talking about today. Now, I want to thank you for coming by offering you a little bit of a opportunity. We'll put your name in a drawing for this cool Apple TV. We'll announce the winner pretty shortly. It'll be before Christmas, so that'll be a nice little present for somebody. So this is Andy Moore. This is KM World. I'm signing off from snowy Maine, and we're supposed to get another 6 or 8 inches tonight. So I'll be talking to you sometime later. Thanks a lot for coming. Appreciate it. Come back again. Bye.